So in this video, we're going to be making a command line version of Wordle, Wordle Classic, the one that you can that you have to guess a word and you get one more try than the number of letters. So we're going to be making a simple version of that just in the command line. All of the output will be printed to the command line. There won't be any type of graphical user interface. It'll just be print statements that we can then see on our command line. So on the left here, I have my command line, and on the left, I have an empty Sublime text window right now. So I'm gonna create a file. I'll just call it Wordle.py, and then I'll open that. So now I have this Wordle.py in the command line. Make this a little bit bigger. And this. So for this, we're going to be using a library called EnglishWords. It's in the Python libraries. So I just installed it with pip, and it's called EnglishWords. And this is where we'll be getting our list of words that we're going to use for choosing a word for the game, and then to validate that the user provided word is an actual word. So we're going to want, there's a few different sets of words in here. The one we're going to use is it's called the EnglishWords lower set, and it's just a set containing all English words. And then we're also going to be using the sys library so that we can have access to the command line arguments. So since it's in the command line, we're going to run it with the if name equals main block. This will be the entry point for our execution in our Wordle.py file. So here we'll create an instance of our class. So we'll define a class, just call it Wordle, and then create an init method where we'll initialize all of our instance attributes, and it will take in an argument that will be letter count. So we'll allow the user to choose the number of letters for the game. And then our actual game loop will be run in the we'll call our main method. Main method is just usually what's used as an entry point to keep everything organized. So we can have helper methods within the class, and then the main method will kind of be like our controller. So then we'll create an instance of our Wordle class. And then we'll call the main method. But we're also going to want the letter count argument, and we'll get that from the sys library. So we'll say so the sys.arg returns a list of the arguments in the command line, and the first item, or the item at index 0, is always the name of the file. So that would be Wordle.py. And then in addition to that, we're going to provide the letter count. So that'll be at index 1. And then just to make sure that the user provides the additional argument, we'll include a try and accept block. So we'll say our argument 1 is .arg, but if it's not supplied by the user, then that'll raise an index error, because we'll try to get the argument at index 1, but if it's not there, then we'll get an index error. So if we get an index error, we'll print a statement, formatted string, telling the user how our class should be used, our game should be used. So then we can say something like usage, and then the name of the file, which again is the item, the first item in the sys.arg list. So that'll be 0. So this would be the name of the file. So we'll say usage, name of the file, and then we'll say letter count. So now if the user tries to run this without providing the additional argument, then they'll see this print statement, and then we'll exit without executing anything else. So now if it's not provided, we'll see this print statement, but if it is provided, then we'll go down here and we'll pass this to our Wordle class. So now if we go back to our init method of our Wordle class, now that we have this down here that tries to get the additional argument, the argument index 1, then we know it's always going to be supplied in order to execute this additional code to get to this point. So we can just check that that's working. We can say print letter count. So to run this, I have Python as an alias. So my Python 3, I just run it with Python, and then name of the file .py, and then this is where we'll provide the additional argument that will serve as our letter count. So I'll just try it with 1. Oh, this should be class. Forgot a colon here. And then this should be arg1. Okay, so now we have now we can say letter count 1. Let me see that it returns this, or it prints that. So now that we know that it's working, each time the user runs it through the command line, they'll need to provide, in addition to when running the file, they need to provide this additional argument that will be our letter count. So now we know that that's always going to be in here. But we also need to check, do some validation for the letter count, because right now this can be run, for example, with letter, so a non-integer. So we try to run it with the letter W, then that will still print. So same thing if we put in just some random characters, that will still run. And we don't want that because we want letter count to be an integer. So we need to do some validation in our init method here. And then if the provided letter count is not an integer, then we'll want to alert the user somehow. So we can do that by raising an exception. So one way to check for the that the letter count is an integer is with the isDigit string method. So we know that the letter count is a string because that is the type of the items in the sys.arg. So we can say if not letter count dot isDigit. So letter count dot isDigit will return true if the string is made up of numbers. Otherwise, it'll return false. So if the letter count's not a digit, then we can raise a type error. This is the type of exception that's usually used to indicate that the value provided is of the wrong type. So we can raise a type error and then provide a message to the user saying something like letter count must be an integer. And then that way, if they provide something that's not an integer, then we should see this error. So we try this now with just random letters. We should see that we got this type error and then a message, letter count must be an integer. So now we have that validated, but we need to do some additional validating because currently now it'll only accept numbers, but we can, as it is, it'll accept any number. So for example, we can put in a very large number, and then that will still run successfully. Here we took out our print statement, but didn't get any errors or anything, so everything ran. So we were to put in print the letter count and run this again. We see it printed out this large number. So then we need to do some additional validation to make sure that the letter count makes sense for our game. So obviously we don't want to play a game where we have to guess a word that's very large, and also we want to maybe have a minimum number of letters for the word, so that we're not just guessing like one letter. So for that, we're gonna add some constants to our class. The best practice for that is to name them with all capital letters. So we're gonna say have two constants, one for the max number of letters, one for the minimum number of letters. So we're gonna say max number of letters equals, we'll say 7. So the max letter count for our word will be 7, and then the min will say 4. So now that we have these two constants, we can check the letter count to make sure that it's between our min and our max. But before that, if you remember letter count, the provided letter count is a string. So first we'll need to convert this to an integer, and then so we'll do that here. And then we'll create an attribute of our Wordle class. So the way you do this is with self.letterCount. So now this will be an attribute of the class that can then be accessed in any of our other methods. So now we can, for example, access self.letterCount in our main method or any of the later methods that we're going to write. As opposed to if we were to say this, then this is still just local to this method. So our letter count, we need to convert it to an integer by calling the int function. So now this should be an integer, and then we need to do this after checking that it's a digit, because if we try to do it before and it's something that's not a digit, then we'll get an error. So we can try that. We try to run this and then try it with our random letters. Then we'll get this error because we're trying to convert these letters into an integer. So that's why we need to put this after we've checked that it's an integer, because now we know that whatever we pass into the int function will be an integer, and it can actually create it or convert it into an integer. So now that we have the letter count as an integer, we can validate it against our minimum and maximum constants. So we can check that in the same if statement. So we can say if self dot letter count is less than self dot min, and then since the constants over here for min and max are also attributes of the class, the way we access them here in our init method or in any other method is also with self dot, and these are actually class attributes as opposed to instance attributes, so they would be the same for all of our classes if we were to create multiple instances of the class, but we access them the same way with with self. So then if the letter count is less than the minimum number of letters, or if it's greater than the maximum number of letters. So if if these conditions, if this statement evaluates to true, that means that the provided letter count is not between our min and max, in this case 4 and 7. So we're going to want to also alert the user. So we'll raise another exception, but this time we'll use a different type of exception. Up here we use type error because that's that if it's a string, then it would be of the wrong type. But now that we know that it is an integer, then it's the correct type, but it's just the value that we don't want. So here we're going to use a different type of exception called value error. So this one's used when the value is of the right type, in this case an integer, but it's not what we're looking for here. So we can say letter count must be between, and then show our min and max. So we use a formatted string for that, and then put in our min. So we'll say letter count must be between the min and the max. So now this will validate that the integer is, or the letter count is, first that it's an integer, and then that it's between our min and max. So we can try this and try it with a really big number. So this should give us the value error. Letter count must be between 4 and 7. And then same thing if we provide something that's less than our min. So we'll say just 1. Same thing, value error. Letter count must be between 4 and 7. And then we can try that with the number that should work. So 4. Then we can see everything ran, no errors. And then try it with 7. Same thing. So now we know this is working. We have our letter count validated to make sure that it's an integer and that it's between our min and our max. So now we'll need to create the other class attributes that will keep track of the state of our game. So we'll do that here in the init method, where we'll initialize all of the instance attributes that we're going to be using. Python doesn't enforce that. You can technically initialize class attributes in other methods. For example, here we're going to be using another variable to keep track of the number of tries. The number of tries will be equal to 1 plus the 1 plus letter count. So if it's a 4-letter word, then there will be 5 tries to guess that word. So we'll need a variable to keep track of the number of tries, and since Python doesn't enforce the you don't have to declare variables, and you don't have to initialize them. So technically we could do something like self.tries equals, and then it will be self.letter count plus 1. So we could do this. We could put this in our main method or in any other method, but it's good practice to initialize your variables in the init method. This just makes it a little bit more readable when someone's trying to figure out what your class is doing. If all of your class attributes are in the init method, then that'll give the reader a good idea of what your class is trying to do. So that's what we'll do. We'll initialize all of our class attributes in our init method, and then that way we can have them all here and then use them within our other methods. So we're going to need to keep track of the tries, and then we're also going to want to keep track of the current row in the game. So each try will have a row, and the row will basically be a word that the user will guess. So we'll need to keep track of the current row in the game board, and we'll initialize that to 0 here because the game hasn't started. And then we'll also need a Boolean to keep track of to flag if the word has been found or not. So we can say something like is word found, and then initialize that to false because the game hasn't started yet. So this will be our flag that we will use to indicate if the correct word has been found or not. So this would be basically the main variables that we use to keep track of the state. And then we're also going to need a list of words. So we'll be using the EnglishWords lower set. So this set contains all of the English words in lowercase. But in our case, we don't want all of the English words. We only want the ones that have the number of letters equal to letter count. So we'll need to extract those from that set. So we'll put those in self.words class attribute. And then for this, we can use a list in here, but we'll use a set instead, because we're going to need to check whether the word provided by the user is a valid word or not. So in this case, using a set is the better option, because sets are hashed. So for example, when we run the end statement to check if the word is in there, which calls the contains method, then it's a bit faster for sets, especially when your sets get very large, than to check if something is in a list, because lists are not hashed. So it would need to check every item in the list to um, know if the item is contained or not. But if it's a set, then it's hashed. So there's a different type of algorithm that checks for containment. So it should be faster, especially with larger sets. So we're gonna create a set, and then we can create an empty set and then do a for loop statement to populate it, or we can do the Python shortcut, the comprehension, um, uh, in this case set comprehension, so we can populate it within the set constructor. The braces are the constructor for creating sets. So we'll say our words will be a set, and we'll say W meaning word, W for W, and English words in our other set. So right now, this would basically create a copy of our English word set. It would just populate it with every word in the English word set. But the reason we're doing this is because we only want the words that are with number of letters equal to letter count. So here we need to add a condition. So we'll say if the length of our word or of the word is equal to the letter count. So now this word set should only contain the words from the bigger set that have the correct number of letters. And then this, we'll also use this to choose a word that will be the word that the user needs to guess. So there's different ways you can do this. We're going to want a random word each time, because just that'll just be the nature of the game, so that you can, each time you run it, you get a different word, and then you actually have to try to guess it. So one way to do this, you could generate a random integer using the random library and then getting the item at that index. But given the nature of sets, which are unordered, the order is never guaranteed. So we can use that here to achieve what we're trying to do, which is to get a random word each time. So we can get an item from our set. One way to do it is with the pop method. So we can pop, this will return a word, and it should be a different word each time. So we can try that. We'll put this in the in a variable, call it word. So this will be the word that the user will actually need to guess. So we'll print that, and then try that with 4-letter word. Line 34, this should, right now it's empty, so an error, so we'll put a pass in here for now. So now we see we got 4-letter word, wool, and then if we run it again, we got a different word, fill, run it again, zone, run it again, doff, foggy. So now this is doing what we want. We're getting a random word each time. But the pop method actually returns the item from the set, and then also removes it. So after, for example, the foggy word is retrieved from our word set, it's removed. But in this case, we don't want that, because we're also going to be using the word set to check that the user word is valid. So for example, if our word was foggy, if we got our word foggy with pop, then it would be removed from the word set. And then when we go to check if foggy is in our set, then that would be false because it's no longer in there. So we're going to want the word to be in the set. So when we check for validation, so you could just put it back in. One way to do it is with the add method. So this would just put the word back in, and it would work. But this is not really the best way to do it. There's a different, better way to do it using the next method or the next function. So this way we can use it to return the word from our word set without removing it. So we can do that with our next. And then the next function actually takes in a iterable. So we also need to use the iter function and then pass in our set of words. So now this will return a word from our word set without removing it. So really quick before that, I can show you what I meant over here. So this the pop method removes it. So now, so if we were to print so after retrieving our word with pop, we can check if it's in there, and this should print false because it's been removed. And then if we add in back our word and then do this same check if it's contained in there. And again, this is what where that performance improvement comes in when we run this in statement. When we check for if word is contained in self.words, we could do this if words was a list or another type of collection, but it's faster with the set because it's sets are hashed as opposed to list where it needs to check every item in the list. So if we were to try this, we can see that our first print was false because the pop removed it, so this should be false, but then we added it back in, so this should be true. But again, that's not the cleanest way to do it, since we basically removing it and then putting it back in, where we could instead use the next and iter functions to just return it without removing it. So now if we retrieve it with using this method, this should return true. So we can see that we have a word and it's still in the set, which is what we want. So now that we have our words and we have the word that we actually need to guess, the last thing we need, two things. We need a variable to keep track of our game board, which is the board that will be, in this case, printed to the command line. And then we'll also need to another one for the keyboard, because in the Wordle game, it also displays the keyboard to show which letters you've used and which letters you've guessed right. So we'll need a game board, and then we'll need a keyboard. So this would be our game board, where we put in our the words that have been guessed, and then the keyboard would just be a representation of the keyboard, and then show the letters that have been used in the game so far. So our game board, this will be essentially a matrix of rows and columns. Each row will represent a word, and then each column will be the each letter in each word. So for that, we can use a list of lists. So again, we'll be using the list comprehension to create our list of lists. So we have our outer list, and then within this outer list, we'll create an inner list for each of the rows. So each inner list will represent a word. So the letters in that word, and then we're going to need one of those for each row in the board. So we're going to need to create a inner list for each. We're going to need one for each number of tries. So if we print our game board, so now we can see we have a matrix, a list of lists. So we can see we have the outer list, and then each of these lists will represent a row, and there should be 5 of them. So we have that here. And then since we're going to be printing our output to the command line, we're going to need we're going to do a method to print that output to the command line. So we can go ahead and do that now, so we can use it as we're building the rest of the functionality. So we'll say print game board, and this is where we'll be printing our game board in the way that we want it to look. So right now it's just printing this list of lists, which doesn't look like a game board. So we're gonna print it like a matrix of rows and columns, so we can iterate through our outer list. So we'll say R, meaning row for R, and our game board, which is a list of lists. So each R should be each of the inner lists. So for each of the inner list, which represents a row, we're going to print that row. So now we can add this to our main method and remove this here. So now we get, instead of this this output, we get one list for each row. But that still doesn't look like the game board that we want, which again will be each row will be a word. So since right now or when the game starts, there won't be any words, because each row will be the word that the user guesses for that try. So once they've tried a word, then we'll add that to the row. But before any of the words are guessed, we can put in kind of a placeholder in there in the meantime. So we'll create another constant for that up here in our class attributes. Call it placeholder, and then you can use anything here. We'll just use a star. So for that, that placeholder is what we'll use in place before actually filling in each word. So we can go back to our game board and then put in the placeholders for that. So we have our list comprehension here, which again is just a different way of doing something like self.gameboard equals an empty list, and then looping through each of the tries, and then saying, and then appending a list. So these 3 lines is the equivalent of this 1 line. This is technically 1 line, even though it's in 3, because it's just you could write it like this. But just for readability, we can make use of the constructors for lists and sets and dictionaries in Python. This will serve as kind of you can go into a new line, and this will still be part of the previous line. So same thing for this. So instead of doing 3 lines here to populate our game board, we can do it with this 1 line. So we can try it with our 3 lines up here, just to show you that is equivalent. So we still get the same thing. And then since we're going to need to populate each of these lists with our placeholders, I'll show you that here as well. So instead of an empty list, we're going to want to add a list that contains the placeholders. So we can go back here and say R for row equals a list, and then same thing, we can our list for each row will be a list of letters, 1 for each of the letter count in the word. So if we have our list for our row, we can say for J, since we already used I, for J in range letter count. So for each of the letters, we'll need to populate our row list, our row inner list, with the placeholder, and then add that to our outer list. So now we should have. So now we still have a list of lists, but instead of an empty list, each of the inner lists now contains a placeholder in place of where eventually the letters of the words will go. So so if you see, we achieve that with these 6 or 7 lines here, but we can actually make use of another well, in addition to the list comprehension, there's another useful Python feature, shortcut feature that you can use to populate lists, especially when you're populating with the same element. So instead of doing this, creating an empty list, and then for each letter adding the placeholder in, we can do a shortcut where we have a list that starts with whatever we're populating it with, and then we can multiply that by the number of times that we want it. So we can say sometimes letter count. So now this line here is the equivalent of the previous 3 lines where we created an empty list, and then we loop for each of the letters and added it to the list. We can do that in one line as well using this. So we can try that. And as you can see, it's still populating with each of the placeholders. So, and then we can actually do that within our list comprehension as well. So we can go back to our just undo this. So that was that one liner is the equivalent of these 3 lines, but we can include that within our list comprehension one liner. So instead of adding the empty list here, we can add in this. So we replace the empty list with this, multiplies it with it populates it with the here we'll need our placeholder. Oh, this should have been the yeah, that was right. So this so if you remember, the placeholder was the star up there. So now this part here will create the inner list with the placeholder multiplied times the number of letters. So I should create a list with, in this case, that star, and then 4 times. And then the other loop here for our range self.tries, we'll repeat that for each number of tries. So in this case, since the letter count was 4, we should get 5 lists, each containing 4 stars. So we can do this with these all of these lines here, or we can do it in just one line using the list comprehension and then this other feature. So these two statements are equivalent. I don't believe there's much difference in terms of performance. So whichever method you choose basically just depends on readability. So sometimes it's easier to understand it this way, read it this way, as opposed to this. But in this case, it's still pretty simple what we're doing here. So doing it in the one line, it's still relatively easy to understand. If you had something like if you needed to check other conditions within the each iteration, then maybe it would make more sense to do it over here so that you can check your conditions there and then append it, as opposed to having all the conditions over here like we did here with our set comprehension. And then also if you had something like if you were doing like a list of lists within the list, so if you had like a nested for loop, you could also do that in here, but then that starts to become a little bit more difficult to read. So then in that case, you would maybe choose to do it this way. But in our case, we're doing something relatively simple, just creating a list of lists with populated with our placeholder. So we'll do that with our one line here. So can get rid of this. So now we have our board. And then now we need to populate our keyboard. So I have that already populated, so I'll just paste it in. So this will be our keyboard. This is a list of dictionaries. So as opposed to the game board, which is a list of lists, um, the keyboard could also be in a list of lists. It could also be just one long string containing the letters in the keyboard. But the reason I chose to do it this way for two main purposes. So if you see here, there's three dictionaries, and each one represents one row on a keyboard. If you look on your keyboard, then you'll see that the first row contains the Q through P, second row is A through L, third row is Z to M. So doing it this way, we can just kind of visualize the keyboard here as it would be on a keyboard, and then this would just make it a little bit easier to print it later when we want to print the keyboard. This will make it easy to print it so that it represents an actual keyboard. And then if that's all we wanted to do, if we just wanted to print a keyboard, then we could use a list. Our inner data structure could be a list, or it could also be a string. And then we could just say for each of the items in our outer list, we could print the list or print the string. But the reason I went with dictionary is because we'll need to update the letters in the keyboard. So in the Wordle game, the UI, when you try a word, if any of the letters in that word are in the word that you need to guess, then it'll change that letter some way. And in the game I played, it highlights it. And then if the letter's in the word and it's also in the correct spot, then it'll also indicate that somehow. So we're going to be updating the letters that are displayed for our keyboard. So we'll need to access each of those letters. So for example, if we had a list here, then we would need to loop through the list to get the correct item, to get the index of the correct item. For example, if we had these letters in a list and then we wanted to change the letter R, then we would need to loop through the list until we found the letter R to get the index. Same thing if it was a string, we would need to loop through each of the letters in the string. But if we use a dictionary and say we needed to update the letter R, since this is a dictionary with the key being a capital R, value being lowercase r, now we can access this easily with capital letter R and then update this lowercase, which would be the actual value that we're going to be printing to the keyboard initially. So that's why I did the keyboard using a list of dictionaries. Again, for the purpose of printing it out, easily print it out so that it represents actual keyboard, and then to access each of the letters to modify them some way to indicate the when the user has guessed the correct letter, or if a letter is used and it's not in the word, then we'll also need to indicate that somehow. So now that we have our keyboard, we're also going to be printing that out to the command line. So we'll add an additional helper method, and we'll say print keyboard. And for this one, we can do something similar. Each of the dictionaries in the outer list represent a row. So we'll say for R in south.keyboard, and then we can say print R, and then call this in our main method. So now we should print the game board and then the keyboard. But right now it's still printing this. It's printing the list of all of the lists, and then the 3 dictionaries. So right now it's a little bit hard to read. So we'll add in a few, we'll make some changes so that it prints more like so that the output's a little bit cleaner. So for example, since right now it's just printing the game board and then the keyboard right after, and it's right after the command that you ran. So we can, for example, add in a header in there. So we can say something like game board, put in header, and then include in a new line using the new line character in there, so that it prints a new line before printing the game board header, and then print the board. And same thing for the keyboard. We can also print in an empty line and then print in a header for the keyboard. So now when we try this, looks a little bit cleaner. Now we can see the game board is here and the keyboard is here. But we still can make this a little bit cleaner. So instead of printing the list, each list for the game board, we can print out a string, because each list contains the letters in the word. So we can print it out as an actual word, or as a string. So instead of printing R, we would need to print we can print a string containing all of the characters in the list. There's different ways you could do that. You can start out with the empty string and then add each of the letters to the end, or you can use the string.join method. So you can say empty string.join, and then this takes a iterable. In this case, R is a list, so we can just use that, pass in R, and then this will basically create a string joined, and then join each of the elements in our list. You can also include, instead of an empty string, you can include something in your string. For example, if you want to, like, a comma separated value, then you can include a comma in here, and then it'll create a string that's separated by commas. But in this case, this will be, each row will be a word, so we'll just print each of the letters one after the other. So we can try this. So now we can see, instead of a list with each of the stars, we just have all of them together in one string, which will represent, each one represents a word. And then same thing, we can do the same thing for the keyboard. We can join a string with, now in this case, each row is a dictionary, as opposed to up here where each row is a list. In this case, each row is a dictionary. So we could just pass in R, and then this will run, because this is, since R is a dictionary, when you just call the pass in the R as the element, it will, in the background, it will call in the keys method. So it will actually return all of the keys and then print those. But in this case, we want the values, because for our game, we'll start out with the lowercase letters. So in order to get the values, we need to call the values method on each dictionary. So now, through each iteration, instead of printing the keys, which you can also use using the keys method, but if you just pass in the R in the background, it'll call the keys method. But we need the values here, so we'll say values, and now we get the lowercase letters, which are the values in our dictionary. But as opposed to the game board up here, where each row is a word, the keyboard is just the letters in the keyboard. So to make this a little bit more readable, we can include a separator in here. It makes sense to just put in a space. So now when we join this string, where our separator will be an empty space, so that we can see the letters a little bit more clearly. So now we have our keyboard, but it's a little bit easier to differentiate the letters. So that's essentially how our output for the game board and our keyboard will look like initially before we start to update the state of the game. So that's essentially everything we need for printing it out to the command line. So now we can go back to our main method. Currently, it's just printing the game board and then printing the keyboard one time and then exiting. But we're going to want to do that in a game loop. So we'll create a game loop. We'll do that using a while loop. You could just create an infinite loop here, like with while true. This would be an infinite loop that just runs until it's killed somehow. But in this case, since we're doing it in the command line, we're not going to have, for example, if it was like via like a graphical user interface or something, you could create a infinite loop and then exit with, for example, like a button on the UI. But in this case, it's all going to be on the command line. So once we enter our loop, there's not going to be any way for us to exit without killing the process. So rather than an infinite loop, we're going to want to check some conditions to let our game know whether to continue or not. So up here we had two variables to keep track of the game state, which is one is tries, number of tries. So we'll need to keep the loop going while there's still tries left. But if there's no more tries, then that's when we'll know that we can end our loop. So we can go back to our while loop and say while self.tries is greater than 0. So while there's still tries left, tries will be initialized with one more than the letter count. So in this case, we'll have 5 tries. So this will be initialized with 5, and we can say while there's more than 0 tries, keep iterating. But then we're going to have to update the tries variable each time so that it eventually reaches 0. So after doing whatever we need to do in our game loop, we can decrease the number of tries by 1 using the minus equals shortcut. So this will decrease the number of tries by 1 each time. So eventually it would reach 0. So now if we try this, we can see that it still printed the game in the keyboard, but now it printed it 5 times. So we have 1, 2, 3, 4, 5. So that's 1 for each time in our game loop. So it came in here each time, printed the game board, printed the keyboard, and decreased the try by 1, and then until our tries reach 0. But then, so that would be if all of the tries are exhausted. But then we're also going to need a different way to exit. So if for example, if the user were to guess the word on the correct try, or in the first try, or any of the tries before the last try, we also want to exit. So that's why we have this other variable is word found to keep track of whether the word has been found. So we can add that as another condition in our game loop. So we can say and word has not been found. So, and not stop.word is found. So now these two conditions have to evaluate to true for our while loop to keep going. If either of them, since we have the and, if either of them uh, evaluate to false, then the entire statement will evaluate to false, and the loop will exit. So if the tries reach a 0 before the word has been found, then our loop will exit. And if the word is found before the try says reach 0, and then it'll also exit. So we're also gonna want to update this in case the word is found. So we can say after updating the number of tries, we can say if we put the word, we're also going to want to keep track of the current word that the user guesses. So we'll create an additional instance variable here to keep track of the current word, and we'll just initialize it as an empty string. So then in our game loop, we can check whether the current word is equal to the actual word that we need to guess. Then we'll update our isWordFound flag to true, so that in the next iteration, when that is checked, it'll exit the loop. So, and then currently we still don't have a way of getting oh, this should be a current word. We still don't have a way of getting the word, but we'll do this in a bit. So now we have that way of exiting our loop. And then since we have those two conditions, or those two paths to exit the loop, we're going to want to print some type of message to tell the user. We could do that here, but we can also add another helper method to do that. So we'll say something like end game, and then this is where we'll print the end message to our user. So then we go back to our main method, and then this one needs to be done after the while loop. So we don't want to include that here because then it'll print or it'll call this for each iteration. So we do that after we've exited our while loop, and we can call our end game method, and then go back here. So if the word is found, so we can check that with our isWordFound flag. So we can say if isWordFound, and then print something. Otherwise, this means that the word wasn't found, but the tries reach 0. So we can print something else here. So if the word is found, we can say something like, so we'll put in a formatted string in here and say something like, put that in all caps, since they successfully found the word. So you found the word, and then it's possible that the word was found with tries left still in the game. So if that's the case, then we can also add that to our print statement. So you can say we found the word with, and then put in the number of tries in there. And then put in some exclamation points in there, and a new line. So now this will print in a new line. You found the word with whatever number of tries left, could be 0. And then, but if the word wasn't found, then we'll print a little bit less exciting message, something like no more tries. And then we can also tell them what the word was. So we'll say the word was, and then put this in quotations, and then we have our word attribute, and then print a new line as well, just to make the output cleaner. So now if the word was found when at the end of the when the loop exits, if the word was found, then it'll print this message and the number of tries that were left. Otherwise, it'll print this message that says no more tries and what the word was. So we can try this. Right now, should print no more tries because we didn't actually have any tries, so it just went through all the iterations in the loop, and then at the end it printed no more tries, and then the word was rack. And then try that again, same thing, went through our iteration, which is currently just printing the game and the keyboard, and then at the end, no more tries, the word was then the word. And then looks a little bit more cleaner. We have the empty lines in there. So now we can go back to our main loop and begin to implement the rest of the functionality for actually playing the game. So we'll need to, in each iteration, the user will try to guess the word. So for example, over here, since the word was vague, each of these tries, the user can enter a 4-letter word to try to guess this word. So we need some input from the user. We can do that with the input function, and then we also have this variable current word to keep track of the current word. So we'll assign that to the input. We'll assign the input to the current word equals input, and then you can also provide a message to the input function that this message will print each time it's requesting the input. So we can say something like put in a formatted string in here, put in a new line, and then we can tell them the number that our tries are left. So we can put in the tries in here. We can say you have this many tries left, and then give them instructions for the input. So we can say enter a valid, because we want a actual word, and then it needs to be a certain number of letters. So we can say dot letter count. So we can say each time we'll print number of tries left, enter a valid number of letters, and then letter colon. So now through each iteration in the loop, the user will see this, which will prompt them to enter some input and then show this message. So now when we go back to our command line, we can see here it says 5 tries left, enter a valid 4-letter word. So right now, we're also going to need some more validation to make sure that the input is valid. So in this case, valid meaning that it's a letter with as many letters as the the letter count, and that was provided, and then also that it's a real word. Um, but currently we still don't have any validation, so we could just uh, input anything, so like just one letter, and then everything will still keep going. So now we're in the next iteration, and you can see that the tries was decreased by one, so now we only have 4 tries left, and then we were prompted to enter another 4-letter word, but again, there's no validation, so we can just put in anything. We can even put in a number, and same thing. Now we have tries left, so we can do that for each of the tries, and then after the last try, then we should see our ending message, which again should be no more tries because we didn't we still haven't implemented the our functionality to to actually try to guess the word. So then so we need the validation in here. We'll need to check for 2 things. One, that it's the number of letters are equal to self.letter count, and then we'll also need to check that it's a valid word. So that, for example, if we say, so we can start with the number of letters. So we can say if len of the current word, so if the length of the current word doesn't equal self.letter count, and then we can say something like print, and then we can put in a string in here and say something like invalid input, and then the print out the input that was provided. So if it's not of the correct length, then we'll print this message, and then if that's the case, then we're not going to want to continue doing the rest of the word game loop. So then we'll need to move this over here. So if it's not a valid word, then we're not going to treat that as a try. We're only going to decrease the tries if the user provides a valid word, but it's not the right word. So that's why if it's not the correct number of letters, then we're not going to want to execute this. So we'll put this down here in our else block, and then can also move this, because if it's not the right number of letters, then we know it's not going to be the correct word. So there's no reason to run this, because it's we know it's going to return false. So in order for the current word to be equal to the self.word, then this would need to be equal. The length of the current word would need to equal the length of the self.letter count. So now we can try this, and we can try one letter. So as you can see, invalid input, F. We would try 2 letters, invalid input, 3 letters, same thing. But now if we try 4 letters, then it goes to our the rest of our game loop. So now that's working. We're validating that it's a 4-letter word, but we need to do some additional validation, the other step, which is to check that it's a real word. Because in that example, we would just type in the letter F. So we want to make sure that the word provided is a actual word. So since we're going to do that, additional validation step, we can create another helper method here. Call it something like is valid word, and then we'll call this here in our main game loop. So this, our helper method is valid word. We'll set it so that it returns true when the word is valid, and then false otherwise. So we can go up here and update this. So we'll need this for our helper method, and then we can change this to if, and then call our helper method that checks if it's valid. So we'll set this to return true when it is valid. So when it's true, we'll go through our game loop. Otherwise, this is where we'll print our message. So now, if we already had this implemented, if it's a valid word, then we'll go into our game loop. Otherwise, we'll print this message. So we can, for example, if this was, if this just said return false, then we know that this would never return true. So then this should always, even if it's a valid 4-letter word like 4, then we see invalid input because we haven't implemented the is valid. So then we can go back to our is valid word, and then this is where we'll check those two conditions. So one will be the checking that it's the correct number of letters. So if it's not the correct number of letters, then we'll want to return false. So here we'll say return false. And then, so if it's not the correct number of letters, then the execution will end here and return false. And then we can add another return statement here and say return true. So if it's not correct number of letters, then this return statement will execute, and then this won't run anymore. But if it's not, then it'll go to this return statement. You could also do this, create a variable for this and say like is valid word, and then initialize it with like false, and then update this variable in here, and then at the end return the variable. That's mostly up to preference. I tend to choose this way. It's a little bit more easier to read, to understand what it's doing, because this way you know that if this condition evaluates to true, then the execution will end here. Otherwise, we'll go to this point. It's just, in my opinion, a little bit easier to understand when you have multiple conditions. For example, we need to check the other condition that checks for the valid word. So we'll do that with the checking our set of words, which again was the reason why we use the set, so that this operation will be big O of 1 as opposed to the big O of n. Every time we check for the contains, it's going to be the constant runtime, as opposed to the checking the list, which we would need to check every item in the list, which can affect performance when you have many items in the list. So we can say if the current word is in our set of words, which we have as words. So in this case, if it's not in the set, then it won't be valid. So we want if the word is not in our set of valid words, and we're also going to want to return false. So this is what I meant by the little bit easier to understand. So we know that if this condition evaluates to true, execution will end here, and then this won't be executed. But if this evaluates to false, then this will be checked, and if this evaluates to true, then the execution will end here. The method will exit here. Otherwise, if both of these evaluate to false, then the method exit will be over here. So we have three return statements, which again, you could do make a variable, and then here update the variable, and then finally return the variable at the end. But that's just up to you, however you want to do it. So then now that we have our isValidWord with checking our conditions, we can try this out. So again, if it's not 4 letters, then this should be invalid. But if it is 4 letters, but if it's not a valid word, then it should be invalid. But if it's 4 letters and it's a valid word, then it should continue with our game loop. And then similarly, if it's a valid word, but it's not right number of letters, then that should also be invalid input. So now we know that that's working. Now we can actually update the state of our game so that the user has some guidance to guess the word. Because currently, as we have now, you could try to guess the word. We already have everything in place to take in a word input, check that it's a valid input, and then check if it's the right word. So you could try to guess the word now, but there's currently nothing in place to help you along the way. So for example, for left, take, so these are all valid words. With lake, so see we already have everything in place to input in this case 5 different words, and then each time it checks if against this word, which was back, but we still don't have anything to make it a little bit easier. So it's very hard to try to guess the word because there's nothing in place to help you. So this is where we need to go back to our game to update the state of our game and update both the keyboard or the game board and the keyboard each time to guide the user to eventually try to get to the word. So that the way that's done in the UI, the iPhone app game, it basically so it puts in the word each time, and then if any of those letters are in the word, then it'll highlight it in a certain color. But then if the letter is in the word and it's at the right spot, then it'll highlight it in a different color. And then same thing for the keyboard. If any of the letters in the word that you tried are in the word, it'll highlight it for you. If it's in the word and it's in the right spot, it'll highlight it in a different way. And then additionally for the keyboard, if any of the letters that you tried are not in the word, then it'll kind of gray it out, meaning you shouldn't really use that letter anymore. You could, but there's no point because we know that it's not in the word. So we're going to try to mimic that here in the command line. Since we're doing it in the command line, we're kind of limited to in our options to differentiate the output we don't have access to, for example, highlighting and colors, things like that. So one way to do it is we can start out with the lowercase letters, and then each time if a letter is in the word, we can change it to an uppercase letter, and then if it's in the right, if it's in the word but it's not in the right spot, then we can also uppercase it, but then we can make it something like italic, so that we can know that that's a letter that we want, but it's not currently not in the right spot. And then for the keyboard, um, for the letters that have been used that are not in the word, we can take those out somehow. And since we already have the placeholder up here that we're using for the board, the game board, we can reuse that for the keyboard and update the letters that are not in the word, update them to stars. So that's what we need to do next. Update both our game board and then our keyboard. So we'll do that with some more helper methods. So we'll create one for the updating the game board. So we'll say update our game board, and then so here's where we're going to want to check each of the letters in the input provided and the word provided. So we're going to need to iterate through each of the letters. So we'll say for C meaning character, for character, and self dot current word, and then do our checking here. So first thing we need to do is check if the letter is in the word that we need to guess, and then do something here. Otherwise, do something here, and then at the end we'll need to update our game board. So we need to update the letter that's displayed on the game board. So when the game first starts, everything is a star. So we need to update that with either if the word is not in the, or if the letter's not in the word, we'll just update it with the lowercase letter. So we'll leave the value that's in the dictionary currently. Otherwise, we'll update it with the uppercase letter or a italicized uppercase letter. So we'll create a different variable here that will be our new letter, our updated character that will be in the place of the letter. So we can say, we can start with the condition that the letter is not in the word. So in that case, we can say, we can leave it as just the lowercase letter. Oh, and then we're gonna want, since we're gonna want lowercase letters, we can come back to our input here and make sure that it's lower, because right now you can run this and then provide an uppercase letter. But if that's the case, we want to make sure that it's everything is lowercase. So we can call the lower method here. And then so in the case that it's not in the word, we'll leave it as is. So then down here, after we've potentially updated our letter, storing it in our new variable letter, we'll update that on our game board, which we have in our list of lists. So we can access that that's our game board. We'll need to access the correct row. So the row will be whatever the current row. So for the first try, it'll be the first row. Second try will be this row. So we're keeping track of that with the our current row variable here. So we're actually going to want to reinitialize it with 0 up here, and we're going to want to update that in our game loop each time. So after each try, we're going to want to update our current row attribute by 1, incremented by 1. So now we'll know which each row that we're on the game board. So go back to our game board. Now we can access the correct inner list for whatever row we're on with our current row, and then this will return the correct inner list, and then now we'll need to update the character within that list. So for that, we're going to need to find the index of the letter. For example, if the word is lake, and then our word contains a, we'll need to update the whatever index contains the letter A. So we need a way to get the index. A simple way to do this here using our current loop is to use the enumerate function. So we can call enumerate, which takes in a iterable. In this case, it's a string. So this calling enumerate on a string will basically return a tuple for each element containing the first item as the index, and then the second item as the actual element. And then we can unpack that automatically here in our loop. So we can say I for index, and then comma C for character. So each iteration in the loop call to enumerate self.current word will return a tuple of a 2 tuple with the index and the element, and then we can automatically unpack it here, assign the index to I and assign the element to C. So now we have access to both the element and then whatever index it's at. So we can use that to update our game board. Once we have the correct inner row, we will need to access the index of that character, and then update that with our potentially updated letter. So set that here. So now if the letter is not in the word, then it'll just leave it as the original letter, and then update it here. But then if it is in the word, then we can start out by making it uppercase. So we'll say letter equals C dot upper. So we'll make it uppercase. So this will update the letter as uppercase, but then we also want to differentiate when it's in the word, but it's not the correct index. So we can say something like if the letter doesn't equal the letter at that index, so whatever letter is at the index in the word we have to guess, then we'll say make it italicized, and then the way you do that is you have to include the escape characters for italicized, and then so that would be this, and then also include this, which returns it to normal characters. So this will italicize our uppercase letter. if the character or the letter is not in the word. So now that we have this, we'll need to call this in our game loop before printing it, because we want to print the updated game board. So we'll call print game board. Update game board. So now this will call this, which will update the our game board, which is the list of lists that will then be printed here. So we can try this. Error line 70. If there should be an end statement here, if cn. So now we have our first try. We can put 4. So if you see here, it added the letter or the word 4 to our game board, but the letter R is capitalized and it's italicized. So that tells us that the word we need to guess contains the letter R, but it's not the last letter. It's not in this spot. So we can try something like rent. So again, R is capitalized, but it's italicized. So that tells us that R is not in the also not in the first index. So we can try true. Again, R is capitalized and italicized. So now we know that since R is in the word, but it's not in any of these spots, we know that the third letter is an R. So we can try something like well, we can we'll just keep going, and then that's just to show you that the game board is updating. We'll try some more words. So here you can see with the letter late, with the word late, the letter A is capitalized, but it's not italicized. So that tells us that the letter A is in the word and it's the second letter. So now we know that the second letter is the letter A and the third letter is the letter R. But we still don't have any more guidance. For example, the keyboard's still the same. So we need to update the keyboard as well to make it a little bit easier to try and guess the final word. So I'll just end this with the same word, just to see what the word was. We can see that it was hark, and we can see that A was in the correct spot, and then the third letter was R. So now that the game board is updating correctly, we'll also need to update the keyboard to make it a little bit easier. Do the same thing with the letters that are in the word. So update those, but all of the other letters, for example, the F and the O and the U that we know are not in the word, we'll change those to the placeholder that we have. So in this case, the star, so that we can look at the keyboard and we know not to try a word with that letter anymore. So we'll need another method here for updating the keyboard. And then need to call this as well before printing the keyboard. So for the updating the keyboard, it'll be very similar to updating the game board. We'll need to iterate through each of the letters in the word, the current word, check that against the word that we need to guess, and then update the letter somehow, and then at the end update the keyboard. So basically all of these lines here won't need to use these. So we could just copy this and do that here, and then continue with updating our keyboard. But since this is this code is exactly the same, we can do something a little bit different so that we're not repeating code. So we can add an additional helper method here to do that that loop, and then call our other methods after, so that we're not repeating that code. So we can say something like update game state, and then here is where we'll update both our game board and our keyboard. So up here in our main game loop, instead of calling the update game board and then update keyboard, we'll just call our update game state. And then here in the game state, we'll call our other helper methods for game board and keyboard. But in the update game state, that's where we'll need this, because this is the shared code that we don't want to repeat. So we'll need to do our checking and updating, and then call our helper methods to update the game board and then update the keyboard. But now, since we created this helper method here, and we're updating the game board with this variable I and this variable letter, these are local variables to this method up here. They're not the instance or class variables. So if we try to run this, we'll get an error. Should get an error. Updating the game state, the game board. Let me see if I saved it. This should not be going. So we're calling updating the game state here. Updating the game board. Oh, because this hasn't been called, so we'll need to go into the actual loop. So if we try to provide word, so now that's when it would go and execute the rest of our code in our game loop. So if you see here, we get this error, name error, letters not defined. We're getting that here because these are local variables that we had access to when this statement was still in this method. But now that we've moved that to a helper method, we don't have access to these other helper method local variables here. You could also create instance variables for this that you can then access over here like this. But in this case, wouldn't really make sense to do that here, because once we check the letters, then we don't really care about them anymore. So it doesn't really make sense to keep track of them for the entire class. We just want them in whatever method we're using them in. So in order to access those over here, we'll need to pass them in to our method. So we'll add some parameters in here. So we'll say update the game board, and then with takes in an index and then takes in a letter. Change this to index, and then up here when we call the update game board, we'll pass in the I and we'll pass in the letter. So now this should work now. So now everything is working. So we can see that the everything ran, but currently it's not updating correctly. So go back here, make sure, look at what we broke. So we're updating the game board with I and letter, passing that index and letter. Um, so somehow something got broken here. Oh, this is so if you see here, this is outside of the for loop. So currently it's just it's going through the loop, and then it's once it's done, then it's calling these with whatever the I and letter values were for the last letter. So this actually needs to be inside the for loop so that it calls it each time for each letter. So now I can try this. So now we have it's working as it was before, but now we have this helper method here that we can use when we're updating our keyboard rather than repeating this code. So just like we did for the board, we need to update our keyboard, but this will be done a little bit differently, where the game board was a list of lists that we could index using indexes. So first with the row number, and then with the index of the letter. We need to do a little bit differently for the keyboard because this is a list of dictionaries. So for each dictionary to access the letter, it'll be simpler because we can access the lowercase letter with the uppercase letter. So if we wanted to, for example, access the letter lowercase c, we can access it with capital letter C. But first, we need to know that C is in this third dictionary, and that, for example, E is in the first dictionary. So to do that, we need to iterate through each of the inner dictionaries. So we'll say for R, meaning row, so we'll say if for R in our keyboard, so each R in each iteration will be the inner dictionary. So we'll say if the letter is in R, so if the letter's in our inner dictionary, then now we know we can access it with our letter. So just like we did for the game board, we'll also need the letter here. So we will need to pass in the letter and add in here, pass in the letter. So now we can access it with the letter, but the letter is going to be lowercase, and our keys, our dictionary keys, are uppercase. So we can access it with letter dot upper, and then now we have access. For example, if the letter was C, then we have letter dot upper. This will be capital C, and we can access the lowercase c, which is what the value that gets printed to the keyboard. So then we can access that and then update it to our new potentially modified letter. So we can try this. So the none of the letters in the word for are in the word. So that's why the game board is still all lowercase, and then nothing got changed in the keyboard. But as opposed to the game board, when the if a letter is not in the word, we're going to want to indicate that on the keyboard. So we'll do that with a by just replacing it with the placeholder. In this case, a star. So we can do that. Since this method here is shared by the update game board, um, we're going to need to do that down here in the update keyboard. Um, so one way we can tell that the letter was not in the word, um, we can again check this. So we can say if letter not in the word, or we can um, check it to see if it's the original letter. So if it remains unchanged, then for the game board, we would want that. But for the keyboard, if the letter remained unchanged, then that means it wasn't in the word, and then that's when we would need to change it to the placeholder. So that should be the better option. So we're not checking the entire word again. We're just checking one character, since we already checked if it's not in the word. So we can add in an additional parameter here, say the original letter, and then up here pass in C. C was the original character in the word, and then down here we can check if letter equals original letter. So if this is true, that means that the original letter wasn't altered at all, which means that this was false. So that means it's not in the word. So for the keyboard, if any of the letters are not in the word, we're going to want to change that to the our placeholder. So now, for example, here, since none of these letters were in the word, then each of these letters would get changed to a star on the keyboard. So we can try this. Um, so it looks like that's still not working. These should have been changed to the stars. So we go back down here. So we're passing in the letter, which could potentially change, but then we're also passing in the original character, and then in the update keyboard, we're checking to see if the letter is equal to the original letter, then we're setting that to the placeholder. So we can add in a print statement here just to check why that's not working the way we intended it to. So we can say checking letter, original letter, and then try that. Okay, so now we have our print statement here, and we're saying checking the first iteration, checking F against F. So that was, we know that it wasn't unchanged. And then that's where it would go here, which should update it to the placeholder. Same thing for the O. So we can add in another print statement here, say update a letter, and then letter. Try that with 4 again. So we can see checking letter F against F. So it did update our letter. So that means there's a problem with the way we're assigning it. So one thing we are going to want to need that use the original letter to access the dictionary, because the letter could potentially be changed to italicized. So when we're accessing the letter in the keyboard, this should actually be the original letter, because the letter could potentially be italicized. So that's one thing. Oh, no, that's right. So this should return each dictionary. Oh, I see. So here the issue is we're so we're iterating through each of the keyboard, which is a row of each row is a dictionary. So this is the dictionary, but then we're checking um, if letter is in R, so if that letter is in the dictionary. But in this case, letter is that lowercase letter and potentially italicized. And when we run uh, letter in R, this checks the keys, so the dictionary keys. So we're checking if the keys if the specific key. So if we were looking for like in this case the letter F, if we wanted to look if F was in the dictionary, we would need to use the capital letter F to check the keys. But here we're checking with the letter. So this actually also needs to be the original letter and uppercase version. Need to check for that in the to check if the inner dictionary contains a key, and then that's how we're going to find the correct dictionary for our letter. So I'll take this out, and that should be why it wasn't working correctly. So and then here, since we're doing this, calling this twice, can also update it here, so we're not calling the upper twice. So we can say key equals, so our dictionary key will be the original letter, the uppercase version of the original letter. And then, so we'll iterate through each row in the keyboard or each inner dictionary, and then check if the key is in the dictionary. And then if it is, then we know we've got the right dictionary. We can access the value, which is be that lowercase letter, and then update that to our new letter. Yeah, so this should be what we need. Okay, so now that's working the way we intended it. So if you see the letter F is still lowercase in the game board, that means it's not in our in the word we need to guess. And if you look at the keyboard, where the letter F, it's now showing a star. The letter O is capitalized and italicized. That's also how it is on the keyboard. Same for the letter U. And then the letter R is also now a star. So that's essentially everything we need to update in our game loop. We have we're updating the game state, which updates both the game board and the keyboard by checking each of the letters against the letter that we need to guess. Updating the game board, doing that index, using the index of the row and the index of the letter, and then updating the keyboard. So this is why I chose to do the list of dictionaries, because once we find the dictionary, we can access the letter that we need to update with that key. Rather than if we had another list. So if this was a list with the letters queued through P, then we would need to iterate through that to find the correct index to update. Here, we already had the index because we're iterating through the word, and then the which is the same length as the word we're guessing, so the indexes would be the same. But over here, we're iterating through the word, which will be of length letter count, which is not the same length as the list in the keyboard. So that's why if we were to have a list here, we would then need to iterate through that inner list to find the index of the letter that we're checking. So using a dictionary, we're able to access it faster just using the, in this case, capital letter. So I believe that's everything needed to actually play our game. So we can test it out a few times just to make sure everything's working. So we'll keep trying with just 4-letter words. So you can say hero. We can see the game board shows hero all lowercase. That means none of those letters are in the word. And then the keyboard, you can see stars in place of those letters. So now this is how we know not to use those letters anymore. We could still use them, but it doesn't make sense since since we know those letters are not included. So we can try to guess different words with the letters that we still have available, that are still showing here. So for example, we can see there's still an F, A, S, and a T. So we can try fast. And then same thing, they're all still lowercase, so it contains none of those letters. We can try pink. So now we got 2 letters. So the I and the K are both capitalized and they're not italicized. So that means that they're in the word and they're in the correct spot. So now we know 2 letters and we just need to guess these 2, first letter and third letter. And our options are the letters that are not stars. So we know it's not pink. So maybe, well, it's not wink or link because those have the N. Maybe. So this gave us one more letter. It's capitalized and it's not italicized. So now we know 3 letters. We just need to guess the first letter. We already used P, so we know it's not pick. So now we can just kind of look at the letter we haven't used and see which one makes sense. So we can try lick, and wasn't lick, but lick is the actual word. So that was probably not a good combination of words to use. But yeah, the word was wick. And we can see that we ran out of tries, but we were close to getting the word. So that everything worked as it should. We can try again with 5 words this time, or 5 letters this time. So we can do sound, and we only got 1 letter, letter D, that we know is in the word, but it's italicized, so that means it's not at that spot. So we can try some other words. That one already has D. We got the letter P, but it's also not in the right spot. We got the letter E and the letter R, but none of those are in the right spot. So now we know 4 letters. We know our word contains a D, a P, a E, and an R, but none of those are in the right spot. We still have 3 tries, so that's 1 more than the number of letters. So we can keep trying using the other letters here that haven't been used, but this is just to show that it's working. So I'll just go ahead and end this by using the same word again to reach the end of the loop. And we see that the word was Padre. So going back to our game board, the first try with sound, we see that the letter D was in the word, but it wasn't in the correct spot because in Padre it's the 3rd letter. Our second try, we put an input. P is capitalized and italicized, which we indicated was also in the word, but not in the correct spot because we see P as the first letter. And then same thing for E and R. They're both in the word, but E is the last letter, R is the second to last letter. So yeah, that's basically it. Looks like everything is working as it should. Um, you're able to um, try it with 4 words, 5 words. I think the only thing haven't tried is the winning the game. So if the word is found, so haven't found any words. So can try that with 4 words or 4 letters, just to make it easy. Um, none of those. So we know it contains a W and a T, and they're both in the correct spot. Um, so maybe um, it's probably going to be one of those words, uncommon words, maybe. Um, so I'll try maybe just the other letters to see if any of those letters are in it. So um, mask. So now we got an additional letter, and we know it's in the correct spot. So we know our first 3 letters are um, W, A, and T. Um, so maybe what? Okay, um, so the letter was what, or the word was what, and in this case, when the game ended, um, we saw the other print message that says you found the word with 1 try left, so we still had 1 try left to guess it. Um, so yeah, that is essentially everything we needed to do to play the game with between 4 and 7 letters. We have our game board, our keyboard. They update to kind of guide us along the way to um, guess the correct word. So we have those different um, differentiations in the game, and we were able to accomplish that with these 126 lines using a few different concepts in Python. So we have use the class. The class here, best practice here is to start your classes with a capital letter. We have our constants attributes, which constant attributes, which are best practice for that is to um, name those with capital letters, and then these are what would be considered class attributes, so that they can be shared between instances of the class. But then down here in our init method, we have our instance variables. So these would be unique to each instance. For example, if we were running 2 games at the same time, or we were to create 2 instances of the class, then the the current word of one instance will be different from the separate instance. Same thing for any of these other variables that control the state that's specific to that instance. And then um, the init method gets automatically called when we create an instance of the class. So we have that here. Made use of a few exceptions, like index error exception to validate that the user provides an additional argument to the command line in addition to the name of the file. and then also have some exceptions. Raise some exceptions over here to validate that the argument that the user provides is first that it's a integer, and then that it's between the minimum and the maximum. And made use of some set comprehension and list comprehension, and enumerate function, which again returns a two-tuple containing the index and the character, or the element. And that's basically it. I'll be including a link in the description to the code in a GitHub repository, and then depending on feedback, I might consider making this into adding a GUI for this, like a graphical user interface to this. And because of the way we did this, we can actually reuse most of this when adding a GUI. So basically, everything up to the only thing that would need to be updated would mainly be these. So the print game board and print keyboard is what prints the output to the command line. But everything else we could reuse. So like updating the game state, keeping track of the game state, we could reuse all of that. And then here, for example, if we had another class like a visualizer class, then we can do something like south dot view dot update if this was like our class that included our graphical user interface, then we would just need to call this to update this with our updated game state. So yeah, hope you found this helpful.